I'm going to present you a French study about the analysis of the accuracy of protocols in robotic milking herds for estimation of 24-hour fat and protein yields and percentage. The development of a number of farms equipped with automatic milking systems is very important in France and in Europe. For example, in France, there were 50 robots in 2000. Now there are 1,900 robots. They represent 4% of farms in milk recording in 2011. French guidelines for automatic milking systems require to collect all samples between 12 and 24 hours. There are difficulties for milk recording organization to organize the collect of the data because the cost is high, the use of sampling equipment is difficult. A new study has been realized to answer some of these questions. What are the aims of this study? There are three aims. First, evaluate the impact of a sample number limitation. Then, evaluate the effect of the sampling period reduction. And last, evaluate the possibilities of adjusting sampling for specific covariates to improve results for fat yields and percentage. In this study, 6 protocols have been tested and compared based on correlation to the 24-hour reference performance. What are the tested protocols? P1, which uses the only first sample collected. P2, which uses the 2 first samples collected. P3 uses all samples for which milk interval lower than 8 hours. P4 is the same as P3 with interval lower than 10 hours. P5 is the same as P3 with interval lower than 12 hours. With P1 to P5, all samples are unadjusted for covariates. P6 uses single sample adjusted for covariates. What are the data sets? There are 2 data sets in the study. P1 to P5 includes 52,000 test day records from more than 250 herds. P6 includes 24,000 test day records from more than 100 herds. Be careful, it's not possible to compare results obtained from P1 to P5 with the ones from P6 where additional information were required. What are cows' performance? With P1 to P5, milk yield is about 27 kilograms and about 30 kg for P6. With P1 to P5, fat percentage is about 4.1%, less than 4% with P6. The 2 datasets show classical performance. What is the effect of a sample number? You can see on this slide correlation between 24-hour and tested protocols. For fat yields, correlation are about 0.96 with 2 samples, 0.92 with 1 samples. And the difference is 4.4% between both. For fat yields, the difference is about 8.7% between both, and correlation are higher than 0.95 for protein yields and percentage. What is the effect of sampling period? This slide shows correlations between 24-hour and tested protocols P3 to P5. For fat yields, correlations are higher than 0.94, and the difference between P3 to P5 is 2.2%. For fat percentage, the difference is between P3 and P5 is 4.1%. For protein yields and percentage, correlation are higher than 0.9 and 6. Be careful. With a reduction of a sampling period, all cows are not sampled. The analysis of results shows, with only one sample, fat yields and percentage are deeply impacted. The impact is limited for protein yields and percentage. With at least 2 samples, correlations are higher for protein yields and percentage, and also fat yields. Only fat percentage is affected. The correlations are 0.93. With a reduction of sampling period 8 hours to 12 hours, correlation decreases for all traits. All cows are not sampled. 22% of cows are not sampled with P3. This decreases to 8% with P5. And what about P6 protocol? P6 is a multilinear regression model based on single sample adjusted. This model considers separate regression for every combination of parity, milking interval, lactation stage, and time of sampled milking. P6 model considers 4 covariates: 2 classes for parity, first lactation, second and other lactations, 5 classes for milking intervals, lower than 6, 6, 8, 8, 10, 10, 12, more than 12, 12 classes for lactation stage, and 2 classes for time of sampled milking, AM and PM. What's the effect of parity on time of sampling milking? On this slide, you can see correlation between 24-hour and single sample adjusted according parity, first and second and other lactation, and time of sampled milking, AM and PM. Adjustment improves correlation for fat percentage and yields around 4%. We don't show large differences according to parity and time of sampled milking. The same table for protein yields and percentage. For protein yields and percentage, adjustment is negligible, max 1%. We don't show large differences according to parity and time of sampled milking. What is the effect of milking intervals? This table presents correlation between 24 hours on single sample adjusted according to milk intervals with previous milking. There is a large impact of intervals with previous milking on correlation. As you can show, for fat yields without adjustment, there is a difference of 8% between a milking interval lower than 6 hours and a milking interval higher than 12 hours. After adjustment, this difference is reduced to 5%. Adjustment improves correlations between 3% to 6% for fat yields, but only 1% to 5% for fat percentage. We can show that for fat percentage, after adjustment, the correlation are still 0.75 with a milking interval lower than 6 hours. The same table for protein yields and percentage. There is a low impact of intervals for protein yields, larger for protein percentage. Adjustment is negligible for protein yields max 1%, higher for protein percentage between 1% and 2.5%. It's still 5% after adjustment between the extreme crosses. To summarize, without adjustments, fat percentage and yields are not very well predicted. Adjustments enable to improve correlations for fat yields and percentage, but correlations are not high, at least for fat percentage in some particular cases, 0.75 when milking interval is lower than 6 hours. Impact is limited for protein yield. For protein percentage, adjustment is interesting when milking intervals is lower than 6 hours. Effects of parity and time of sampled are limited, and the impact of milking intervals is high for all traits, especially when the interval is lower than 6 hours. In conclusion, this French study shows that a restriction to a single sample unadjusted has a large impact on the accuracy for fat percentage and yields. A reduction of sampling period to less than 12 hours has an impact for fat percentage, and all cows are not sampled. A protocol with at least 2 sample milking gives interesting results. Adjustment for a single sampled milking needs to be carefully analyzed. It's important to compare results with other reference. And before adopting any protocols for genetic evaluation, it's imperative to ensure they are unbiased and reliable. Thank you very much for your attention.